SOFTECAsia 2025 commenced with the first keynote entitled Transforming Quality Assurance Using Artificial Intelligence, a CIO or CTO perspective. Now, ladies and gentlemen, this keynote speaker needs no further introduction, but nevertheless, I'd like to give a few words of accolades to him. This gentleman is a distinguished university professor of information systems at the University of Memphis, Tennessee, where he also served as the Executive Vice President of Research and Innovation and as Executive Director of FedEx Institute of Technology. He is one of the earlier pioneers in the validation of AI and on explainable AI since the 1990s, right, when he first published research on this topic. Ladies and gentlemen, please welcome Professor Dr. Jasbir Dhaliwal, University of Memphis, United States of America.
Puan Aziza Hamza, Directors of MSTB, my fellow speakers here at SOFTECAsia, and delegates, Selamat Pagi. Thank you for inviting me back again. It's always nice to come home after a busy 30, 40 years now, my career in the US and in Europe and Canada. So before I start, it's the relationship between the FedEx Institute of Technology and at the University of Memphis and MSTP is a very deep one. It goes back to about 1 year before MSTB was launched, and the first SOFTECAsia was organized in 2008, I think. And at that time, the Y2K, some of you will remember the Y2K if you're as old as I am. That's called the golden age of testing. Right, because every CIO or chief technology officer of large corporations were really sweating that on the day 2000 will come and all their software systems will stop working because the year, remember 2000, was defined in 2 digits rather than 4 digits. So it was literally a hunt. The outsourcing, the international outsourcing industry was born then, because CIOs, CTOs needed a lot of help, and that persists today. As a matter of fact, outsourcing of software testing is actually growing even today in that sense, which is a good thing. And I think this is when Malaysia saw the opportunity to be players in software testing. So I want to commend the MSTB for doing a phenomenal job over the last 20-something years. The program that I founded at the University of Memphis called the Systems Testing Excellence Program was born just a few years earlier. Now, at that time, things were very different. Software testers were regarded as the second cousins of software developers. Very few developers wanted to be testers. A lot of developers thought that testers were a nuisance in some ways, right? And then there was this big debate whether all software engineers should start with testing first and then go and become software engineers, because then they will code better. If you know, how to catch defects and if you know about the dangers of poor quality software engineering, you can do better. So at that time, there was an international movement that kind of said, how do we change that? How do we make quality, software quality assurance of high quality by changing the role of testers? Changing how testing was done. Some of the ideas that came out of that international debate was, 1, make testing more scientific. 2, separate testing away from development and make it its own field. And the third thing that came out of the software quality assurance movement at that time was, we need to certify testers. We need to certify testers in every country globally. And ISTQB, is the organization that has done a phenomenal job, a wonderful job internationally. So it is an international certification for testers, right? And that has really boosted the quality of software testing, to a much higher level. And on our side, I come from academia, and the STEP program said, look, we want to improve the science of software testing. And again, we have made great strides together as an academic community internationally. But there's another dimension to it. You can't have the academics working separately. I remember being at some conferences, IEEE and ACM, large testing conferences in the US and in Europe, and the practitioners will come and say, you know, all these professors are talking, and I have no idea what they're talking about. They're talking about algorithms, but I manage software testing in a business organization. So that's when my program, the Systems Testing Excellence program said, we will work to make software testing accessible to managers, to chief technology officers, to chief information officers, so on. So we took on that mantle. We still want to do the science, but the science must be translatable and understandable to the leaders in software engineering organizations. So that has been a mission we have been on for many, many years. So that's a little bit about the background of the FedEx Institute of Technology. The FedEx Institute of Technology is funded by FedEx, which is based in Memphis. And so we have a long history of collaboration together. As a matter of fact, the main role of the FedEx Institute of Technology is to serve as the eyes and the ears of FedEx in the academic research space. So my job is to watch out all the developments going on in research, in all fields of research. And then every 6 months, go back to FedEx and say, here are some technologies you better be careful about. Here are some technologies that can give you competitive advantage. And some of you will know one of the technologies that, that can really impact FedEx in a big way is, remember you all hear about rockets going on into suborbital space and coming down, right? 40 years ago when I left Malaysia to go to Canada to do my PhD, it took me about 26 hours to fly there. Now today, 40 years later, it still takes the same amount of time to fly there. Why? Because of the sound barrier, right? The planes can't go beyond the sound barrier, otherwise the ride gets very uncomfortable. Well, now with rockets going on into suborbital space and coming down, now that's a new technology. It is doable. We are even taking tourists to space. Guess what? FedEx doesn't ship tourists. FedEx ships packages, right? Throw a packet in a rocket, goes up, comes down, lands in Kuala Lumpur or maybe in Port Klang on the water, and you have cut down the time, for a package to move from Memphis to Kuala Lumpur from 26 hours to 4 hours or 5 hours, right? So that's the role the FedEx Institute of Technology plays. We watch the technology, and we are the eyes and ears. We are the academic eyes and ears so that FedEx constantly stays at the cutting edge. That's our role in that sense. So it's a very special relationship that has been very successful for a long, long time. Now, what else can I say? AI technology is absolutely a transformating technology out there, right? It is a revolution taking place right in front of us, right? But, which is great, but there are some troubling dimensions to it. And the biggest troubling dimension is enterprise AI is not working. AI as a personal productivity support tool for you, the professional, whether you're a tester or whether you're a musician, doesn't matter. AI is helping you function as a professional, but enterprise AI is in trouble. And so part of the interviews that the FedEx Institute of Technology did was, where a CIO, Chief Technology Officer, sometimes I use the term interchangeably, CIO or CTO, of a Fortune 500 company calls my office, wants to talk to me and says, look, I keep hearing enterprise AI is in trouble. Can you tell me why? Can you tell me how we should do it differently? And he says, look, we don't want to put control on AI. We, like Mao Zedong said many years ago, let 1,000 flowers bloom, right? For AI, this is the moment where you want every single individual like you out here to be experimenting with AI. Now, at a time when you want everyone to use AI, you shouldn't be putting controls away too much, right? But at the same time, if you're a chief technology officer of a Fortune 500 company, your job needs to make sure that the software that you produce works in that sense. So in some ways, it's kind of a contradiction. So today, I'm going to share some results with you. Now, we promised the CIO we will do a study. So as part of the study to date, we have interviewed about 33 members of the Society for Information Management, which is the largest industry group of CIOs and CTOs in the US. We have interviewed 33 of them, and those interviews keep going. And then we are going to report back to this CTO and tell him or her what his approach should be to making enterprise AI work. I'll come to that in a while. But it's really interesting. I'm 67 years old. I'm at the tail end of an academic career, that has lasted so long. And guess what? One of my sons pointed out to me that the first research paper in my whole life, that I wrote, it was in 1988. And the title of the paper was Validation of Knowledge-Based Systems. That knowledge-based system was what AI systems were called at that time. The word AI wasn't used very much. The American Association of Artificial Intelligence, AAAI, had just been set up, and that was the first generation of AI. So AI is not new to us. And my paper, you can look up this paper. It's a really interesting paper. It is still relevant today, trust me. Right? It's in a journal called Knowledge Acquisition, because at that time the challenge was how do you acquire knowledge to put it into these intelligent systems and then business can use these intelligent systems, right? And part of the work in that paper was driven by nuclear power stations, right? In a nuclear power stations, you cannot have anything go wrong. Any software that is used in a nuclear power station, right, has to work. So you better test it really well. So when the pressure to test is so great, right? That's when you can study testing at the best level. So again, like I said, at that time in 1988, we had recognized that testing of AI systems was going to be important. Now, it was very interesting. At that time, there were two different paradigms in AI, right? And now it's important that you understand that because in history, you will find the answers. Right? Because AI is not a new revolution, you know what I mean? The technology has been around for a long time. It's just that now it has become an industry buzzword, right? So at that time, we did recognize that validation or testing was really, really important for AI systems. Now, the two schools of thought was like that. One school of thought was led by someone who won the Nobel Prize, Herbert Simon. Some of you will know him. He was at Carnegie Mellon. And he says the best way to build intelligent systems is to model the human mind. If we can model the human mind, we can create AI. Now, the other camp, and I was at many conferences where these two camps will be really debating each other, right? And the other camp was the machine learning, neural networks, computational AI, whose premise was that we need to create algorithms, right, that can lead to intelligent behavior. So these two groups, one came from a more psychologist, cognitive science background. The other one came from math and statistics and electrical engineering. So there were a lot of debates. And guess what? The knowledge-based camp of Herbert Simon won. And the leader of the machine learning group was a professor called Chandrasekhar at Ohio State University. And Ohio State and Carnegie Mellon are not very far from each other. And it was an interesting time. There was a lot of money in science for AI research at that time, too. And both of them, ultimately this group won and this group lost. But then around Y2K, the whole focus shifted from that generation of what they call expert systems to Y2K and other challenges. And when it came back, machine learning and AI rose to the front. Why did that happen? One, the computational power, did not exist in 1988. Today, with GPU chips and whatnot, right, data centers everywhere, the computational power is readily, cheaply available. Two, at that time, the data was not online. Now, virtually everything, all data, there's so much data online, we are barely touching 5% of it in that sense. Now that the key elements, now nobody talks about the Herbert Simon movement. I'm sad to say I was part of the Herbert Simon movement at that time too, right? Even my doctoral dissertation in 1993 was about explainable artificial intelligence. So this is not new, right? This is not new at all. And now that this other side has won and generative AI is really lighting up the fire, right? In terms of how many things it can do, it's going to change our world, and it is, right? So I want you to understand that because it's really important, right? It impacts how testing is done, right? Finally, if you notice, software quality assurance, which was largely certification-oriented at that time, has moved into different places because now there are clouds, you have to test, hardware that you test. So maybe the word software is kind of a little bit different, right? Now, the key thing is this, even though there's this exciting new technology out there, how are we testers going to respond to it, right? Are we going to be saying it requires a completely new way of testing? Or does it mean we should look at the science of testing right from day one and say, how do we make some tweaks here and there? I think, now my argument to you will be, don't start afresh. AI may be exciting and has huge applications to change our lives, but how we test, science is always constant, right? You cannot change the laws of physics. You cannot change the laws of biology, right? So the principles of software testing and software engineering are consistent as well. Otherwise, we are not a science, right, in that sense. So I want you to think very carefully about this because these are really important aspects. Now, just one last thing at the bottom. The science of software engineering and testing is based on systems theory. And systems theory is fundamental to how we develop and test software. So the principles still apply. Like, for example, one of the principles is you always test in the small first before you test in the large, right? If your unit testing hasn't been done, don't even try doing integration testing. Because then if you find some bugs, you won't know where they came from in one sense, right? Now, that's a fundamental principle of systems theory. Same thing, regression testing, right? Regression testing is a fundamental principle of the science of software testing. If you make a change to a system, or you add on a new module, or you bring in a new technology, you have to regress the changes right across the whole section in that sense, right? Like, for example, FedEx is in 200 over countries. They have millions of lines of code across how many systems. When they make one ticket comes in to change one item, they have to regress it over all the entire system to make sure there are no unintended interface defects. Those are the biggest defects. In most Fortune 500 companies that are global, 70% to 80% of the defects are interface defects, right? So regression testing is really, really critical, right? And sometimes we in software, we forget the core. Some of you may have heard about a company called CrowdStrike, right? CrowdStrike, was it 6 months ago, last July or something, they sent out a new release of their software, and it failed all over the world. And Delta Airlines couldn't fly for a few days because the software just didn't work. And then later they found out they hadn't done regression testing in a good way. So sometimes even during in the new world of AI, right, exciting world of artificial intelligence, we forget to do the basics. And that's really important, right? I like to emphasize that. Great, so like the point I made just now, right, it's a really important point. Today, there's mass adoption of artificial intelligence. I bet all of you are using it. As a personal productivity tool for software testers today, AI, generative AI is phenomenal, right? You want to generate test cases, use cases, right? You want to find test results, but testing is full of data, right? You want to find a whole bunch of them and then try to summarize them to know where the risk factors are. Generative AI is going to be very, very helpful for you in that sense. We know that, right? But even though there's, as a matter of fact, the amount of time it has taken generative AI to reach 100 million users is shortest of any technology in history. Shorter than spreadsheets, shorter than laptops and PCs and cell phones and other technologies. It's so mass adoption now, which is great, right? But the question is, why is it not working for enterprises? And here are some studies. Now, this is a study from MIT. I think it was featured in Fortune magazine, where they interviewed 150 executives, right? This is just a few days ago, in August 21st, 2025, just 2 weeks ago. 95% of AI pilots, enterprise AI pilots, fail. And And the reason this CIO had called us a month ago was because he knew this was happening. Even in his own organization, enterprise AI was not working. So then there was another study, Capgemini in 2023 said 88% of enterprise AI pilots failed to even reach production, right? Same thing, S&P Global found earlier this year, 42% of enterprise generative pilots were abandoned, right? So this is a really important concern. And as we were doing these interviews, these CTOs were asking us, why? How can it be better? And whether testing has a role at all or not. So I think if you all work in large organizations, I'm sure, right? So you need to think carefully about this. Why are these systems not working? And that's really what our study, you know. Now, we have a long history of, hold on, I think I missed a slide here. Yes, this is a slide I missed here again. Now, you may say, why do we want to study a chief technology officer? Now, the way research and theory work is like this. There are cycles of what we call induction and deduction, right? Most often science starts with somebody observing something in the real world, right? Which means once you observe something, right? Like for example, if it rains, people put out the umbrellas, right? If you observe that, it starts with data. Now, and then other people would sit there and say, hey, why do people open the umbrellas when it rains? So then they start conceptualizing and then a theory emerges. And then someone will say, yeah, we have a theory now, but we need to go and test it. So we go back to the reality again, right? So theory building, or the science of testing, is built in cycles of induction and deduction. First we start with the data, then we conceptualize, theorize, then we go back to the data. So induction, we call them the cycles of induction and deduction, right? In philosophy, it's a known fact. This is how science moves forward. This is how best practices in industry move forward. So my center, the Software Testing Excellence Center at the University of Memphis, we do very scientific work. By the same time, we talk to industry all the time, because that's where the data comes from. If it's a concern to a chief technology officer, it's a concern to us who are building the science. So that's really important, right? And now the other thing that we guessed very early in this study was you must separate testing of AI systems, right, from testing or using AI for testing, right? Like I said, you are all probably expert at AI as a personal productivity tool in your testing work. But how do you test large-scale generative AI systems, right? How do you validate an enterprise LLM model for your company or for your industry or for your segment, right, in that sense? So I think as testers, that's the first thing you need to do. You need to separate those two things and put them in different buckets, because once you do that, then you will have a good sense of how to separate the two, right? So the question is, do we need a different kind of a tester, right, today given AI? Then the other question is, we made a lot of progress over the years in the science of testing, and you all have heard about the shift left movement, right? In the old days, testers only tested code. Then somebody said, no, you have to test the designs too. And then it ended up all the way to have requirements testers, right? The shift left movement, we call it, right? From the right all the way back. This is, if your requirements are wrong, your systems will fail no matter how well you test the code, in that sense, right? Now we have been talking about it for 20 years. Is that still true today with generative AI, right? Or is the role of generative AI to help us produce better requirements, right? So these are things that we need to think about very carefully, right? Now, so I'm going to go through a whole bunch of things that came out of our discussions with the chief technology officer, right? If you work for a chief technology officer, this is how they think. So these slides will help you how they think. Now, all these Fortune 500 companies for a long time, the CTOs have been concerned about what's the ratio between testers and developers. They have been talking about it for a long, long time, right? FedEx at one time had 3 developers for 1 tester, and they were using the software development lifecycle. Microsoft, at that time, we did a study on that, had tryouts. They had a software developer, a project management person, and a tester. So essentially, they had one tester for every developer. So I remember Microsoft came to Memphis to study, wow, how can FedEx do it so efficiently using the life cycle? And FedEx was interested in going agile too. They were saying, yeah, we want to be more agile too, like Microsoft, but hey, we don't want to break this ratio of 3 to 1 or 4 to 1 because that's very efficient. We can do testing so much efficiently. So I think AI is challenging that, right? AI is challenging that. Now, you have heard a lot of, the trouble with our technology industry is there's always so much hype in our industry. Sometimes the hype, kind of hides away the reality of it. No, AI definitely can produce code for you, but that code will always be brittle, very brittle in that sense, right? And so which means that's why you may hear some companies saying, we are going to hire less coding people. But have you seen a single study that says we are going to hire less testers? No, you don't. As a matter of fact, your job is safe and secure because the more AI is used to produce code, AI code is brittle, the more testing will be required to make it real, to make it functional in that sense. So in some ways, CTOs are starting to think along that line, right? Wow, okay. So are testers cheaper? Because when you have a bottom line to manage, you always think about cost, right? If I need, are testers cheaper than coders in that sense, right? And so that's a really interesting discussion because based on this big revolution going on around us, did I just drop something from somewhere here? I think it came out of. Can everyone hear me? Okay, good. I'll just drop it off. Yeah. So the key is these kind of issues are really, really important to CTOs. Most of the CTOs think that the new type of coders will have to be better testers because AI can generate a basic code for you, right? But that code is going to be very, very brittle. So now there's another study, of two companies, Coinbase, the Bitcoin exchange, and also Ignite Tech, which is another large company. In studies of that companies, they find the biggest people resisting AI are software developers. Can you see a minute? It's not the people out there, not the users. Software developers are the resistance to change in the AI industry. So again, that's another important thing that CTOs are concerned about. And so they're looking at what's a new type of tester going to be, who will use AI to generate code and test it. So that's going to impact a lot of our work, a lot of our science as well in that sense, right? Now, let's see, did I get this right? Okay. So that's one issue that is coming out of our interviews with CTOs. Now, another issue is technical debt. Most of you may not understand this term, but for chief technology officers, this is a big one, right? It's another way of understanding it. I think the second point here will understand outdated infrastructure, outdated applications, right? Now, no chief technology officer gets a budget every year to renew the whole IT budget. That means there's hardly a company in the world that has completely new architecture, or networks out there. Essentially, smart CTOs, they space out the technology. In other words, in a 5-year cycle, every software, every hardware should be updated. Now, if it's not, that's your technical debt. And that technical debt is going to hold back innovation. That is going to hold back AI. A lot of the software and all the software and hardware that enterprise AI has to work with is not at the cutting edge. And if it's not at the cutting edge, how do you get AI system to interact with them? So that issue is, a lot of CTOs are losing sleep over it. So as a matter of fact, in one company we found, the CTO tasked the testing organization, you are going to help me manage technical debt, right? I'm going to listen to you folks to tell me which is the system that needs to be updated because roughly 15% of, in large Fortune 500 companies, 15% of the IT budget goes towards renewing the architecture. So this is a really big issue. This is the reason why we may be finding that enterprise AI is not working because the legacy systems with which they have to interact with, from which they pick up data may not be working in that way. So this is a real big issue. I mean, there are some points in my slides you can look at. There's some wonderful articles. We have, at the University of Memphis, we have a professor who hired recently who just works on this topic all the time, because we see that as a huge issue, holding back AI, enterprise AI on large-scale applications and modernization in that way. Now, the other thing is, AI has just taken us by storm. But what was CIOs talking about a few years before that? The rage was digital transformation. I remember even SOFTEC, one of the themes of SOFTEC was testing and digital transformation. Now, digital transformation has not gone away. As a matter of fact, AI has made it even more important today. Why? Because it has sped up the pace of digital transformation in organizations, right? And at that time, we were talking about, a lot of remember the CIOs in the 80s and 90s became chief technology officers in 2000 and so on. And then in the 2010, they all wanted to become chief digital transformation officer, chief CDTO. Today, some of them want to be chief AI officers in the organization, right? But they still want to do the full set of work in that way, right? That means I want to be known as a CAIO, but I'm also functioning as a chief digital transformation officer. Now, the important point is the 4 dimensions that are laid out here. Digital transformation involves really complex changes to the organization. Your processes change, your structure change, even your brand changes. Remember, so again, remember if you notice, process transformation, business model transformation, cultural organizational transformation, mindset transformation, and then domain transformation, right? Digital transformation was about change in a holistic manner. Now, AI is making digital transformation speed up, which means it's impacting all 5 of this. And enterprise AI may be failing because we are not taking a digital transformation approach to it. We're not considering that 5 things. We are just saying, here's AI, let's play with it, let's use it, right? But the enterprise architecture is a digital transformation architecture. So it may take, I've spoken to some experts who think it'll be 10 years before the true potential of AI for the enterprise will come to the front, the true benefits. Until we ourselves understand what AI can do, right? And let's not forget, when the internet came in about 1995, don't forget in 2001 there was a big crash. Only after the crash, the internet didn't die or go away. Then it came back in better form. Virtually every organization jumped on, and new business models were born. And a lot of people are now predicting the same thing will happen with AI. This is really the experimental stage. That's why it's not working at the enterprise level in that sense. So there'll be a big crash, and then before we figure out this works, this doesn't work, and then also it gives us time to make all the 5 changes in that sense possible. So if you want to talk to your CTO, try to translate AI not as a revolutionary new technology, but as a catalyst of digital transformation. You'll be much more successful, right? As an IT manager or a software testing manager. So remember, this is a really important relationship, and it's at the heart of why enterprise AI is not working. Now, of course, in the commercial B2C marketplace for AI, there are a lot of concerns, a lot of concerns with sexism and racism and other kinds of things, because what are large language models? They're basically going to what's out there on the internet, right, and getting it up very quickly for you based on some algorithms, right? And of course, our internet is not perfect, right? So there are a lot of things out on the AI, a lot of things out there on the internet that are not perfect. As a matter of fact, I know some research groups who are just out there to try to change the balance of what these large language models are going out there and picking up, right? So if you have an organization that has built a reputation on quality, on serving people with respect, right, and making sure you don't, the young people who use your technology don't commit suicide, and good fundamental human values, right? And then you can't let AI run rampant among your customers or even in your organization or your infrastructure. This is a huge issue. Now the question becomes, who in the organization should be responsible for this? The chief marketing officer, the chief legal officer, like many large American organizations are doing. Well, some CTOs think it is their responsibility, right? If you manage IT, the IT architecture, the applications, you have to watch out for your organization as well. So this I'm seeing in our interviews, we are saying a lot of CTOs are concerned about this. Some of them are taking this, they're saying this is our responsibility too, right? They are setting up units of the organization that are monitoring this. Some have been told by their CEOs, go do it, because we don't want to, we can't have all these lawsuits on our hands. So this is a really fundamental. Some of you may be interested just a few days ago, right? Just a few days ago, I think about a week ago, Harvard Business Review, every year they do a study of the marketplace and see what are the top 25 users of AI technology, largely generative AI, right? And right from day one, a few years ago, 2002 and so on, it was always generating ideas, right? Helping to do some calculation. This year, for the first time, the number one issue is companionship, loneliness, therapy. Can you see me now? Wow, AI systems, how people are using AI systems in the B2C marketplace is changing. So now, if you are going to offer applications of AI, is your organization ready for this kind of responsibilities? So this is really important, right? So check this out. Go and Google Harvard Business Review, top 25 users of AI. Just came out, I think, about a week ago or 2 weeks. Now, we have seen this trend coming, We have seen the trend coming. I guess if you don't have a digital buddy yourself, your children do, definitely, right? And so AI is going to be, changing how the consumer interacts with your organization as well. And IT has to take some responsibility for it too. Now, again, like I said, my research group focuses on history, and how we have improved the science over the years. We are also very interested in how CTOs think. That means we scientists can't just be in our labs doing the science, right? And now it's very interesting in this. If you go back to 1960s, and now I was just a young boy in 1960s. I'm not that old, folks, right? But I know what was going on, right? The developer or a few coders will come to your office and say, what do you want? Okay, they'll write down on the back of an envelope a few points, then they'll disappear for 6 months, then they'll come back, your system is ready. That was the only interaction. Some of you, if you're, laugh at that. Now, my question to you is that the state of testing in AI today? Right? Is that happening in your organizations? Right? Now, if that is happening in your organizations, you've got to think carefully about it, right? Do we want to go back? That means all these 30 years of the science of testing, right? All the certifications you have taken on, right? Surely we can do better. So give that some thought. And then, of course, we became a little bit more scientific. We came up with the software development life cycle. We said, let's take the whole software development process, chop, requirements, design, code, and then before you implement. And then, of course, that was wonderful for us, for us testers. Why? Because now there was a stage called testing. And there was a bunch of professionals called, we are testers. We are a family, right? We are professionals too. We have our own science in that sense. So the software testing life cycle was very, very good for that, right? Now, are we applying, my question to you is, are we applying the software development life cycle, right, to AI applications as well? Can you see me now? Or are we applying AI to requirements, to design, to coding? We know we are applying, there are enough market data out there, and a lot of studies and a lot of presentation on how you can use it for coding, right? We know we are using it to generate test cases, right? So again, think about a life cycle. What does AI do to the scientific software development life cycle, right, at each one of our stages? Is coding becoming less important and testing become bigger, like I argued just now, right? Your jobs are safer than the coders' jobs in that sense. Think very carefully about this. And there's very little scientific studies on this yet, because the whole phenomenon is so new. But it demands our deep thought. You know what I mean? And CTOs are very interested in it, right? Many large Fortune 500 companies have their own software development life cycle methodologies in their own organization. They have manuals this thick of what you have to do, step by step to develop software systems. And now AI has come and changed that. Are we ready for that, right? So now, of course, a lot of Fortune 500 companies, the SDLC became too cumbersome, so we came up with prototyping. Then we moved on to agile and extreme programming, right? All the new methodologies, right? And then, of course, the folks who worked with Carnegie Mellon, right? Carnegie Mellon Software Engineering Institute, they came up with CMMI, right? Some of you will know that, right? Whereby there's a software development process and then there's a validation process. Remember, they're a parallel as well. And that worked for a lot of organizations too, right? Because not every organization is the same, right? So we in testing must be open to diversity of approaches, right? The question is, we have learned a lot about where prototyping works, what kind of systems. We also know where software development life cycle. So never be, the hardcore person that says, no, everything must have SDLC, or everything has to be prototyping. Can you see me now? CTOs don't believe in that, right? CTOs spend a lot of time questioning the software engineering department. What is the methodology for this application, right? So the question is, can AI be developed using the SDLC? Maybe it might be better in enterprise AI applications. Can you see me now? So give that some thought as well. So basically, the chief technology officers are seeking assurance. They don't want to go back to the Wild West days, when, step number one here, the white elephant systems, where some organization, I know banks that spent $100 million at that time and then ended up with a system that wasn't working, right? So we want to make sure we understand. Now, as the science of testing has exploded, right, become stronger, our roles as testers has changed as well, right? We have done studies in the past where testers sat down and told, what is your main role? And here are some different things that they used to tell us, right? And guess what? Every new technology that comes, our role as testers expands, right? We're not just doing testing. We are also execution watchdogs. We are also service providers, right? We are also certification authorities in some large organization. We are also test automation experts, right? Because we need to apply automation to our own work in that sense, right? And as a matter of fact, the big transformation in computer science in the last 30 years is not so much the technology, is how computer scientists have taken automation and applied it to their own work, right? That's why, so much of software development can be automated today, and same thing, so much with testing, so much of testing as well, right? In that sense. So our roles keep expanding. So a lot of chief technology officers are concerned about that, because many of them have even go back to their CEO and say, hey, the testing department's budget is the same, but our role keeps expanding, right? And some of them, I think you'll hardly find a chief technology officer anywhere now that says, oh, we just need one type of tester. The testing department is a very diverse place, because testing has expanded into so many responsibilities, new responsibilities, and AI is putting more on them, right? Now, every single CTO we met knows about this paper that comes out of Columbia, right? Narayan and Kapoor. It came out in April this year. Every CIO in town knows about this paper. And the paper is basically, the title is AI as a Normal Technology. You should Google this, AI as a normal technology. The paper is available on LinkedIn as well, right? It's not a long paper, but it takes an economics approach to trying to understand how we should manage AI, how should we test AI, right? Because I think CIOs and chief technology officers are increasingly starting to understand that we cannot manage AI as a revolutionary technology. We must manage it as a normal technology, because every few years, the tech industry comes up with a new buzzword, a new technology. And I won't spend a lot of time on this slide, but I think it's really important to understand that the moment you change your mindset about AI is just nothing but the latest phase of technology. Just like some years ago was digital transformation, before there was data warehousing. Trust me, in 5 years, there'll be a new one as well. If you can take that mindset, CTOs have that mindset. And they're talking about this paper in a big way. So I think if once you read this paper, make sure your chief technology officer, send it to him and say, hey, this is what people are talking about in North America. What do you think? You know what I mean? It will help you understand how the role of testing should happen, right? Now, another fundamental point that chief technology officers are really concerned is efficiency and effectiveness, right? Many of us in our daily language, we use the term interchangeably. Oh, this is efficient. Yeah, it's effective too, right? No, they are completely different concepts, right? Efficiency is about getting the most output from the least input, right? And effectiveness is nothing to do with, you can be efficient, but that doesn't mean you're effective. Right? Somebody can come to this stage and give my whole talk in 5 minutes. They're very efficient, but they may not be as effective I am, right? The reverse can be true too, right? So understanding the efficiency and effectiveness dimensions is really, really critical, because software development and coding have always been very efficiency-oriented. Software testing has always been effectiveness-oriented. And those two things constantly have been clashing over the years. And now AI may be changing that dramatically, which means software development as a science will have to change, right? So I won't spend a lot of time again. Like I said, the two paradigms of efficiency and effectiveness that have dominated the conversation in IT shops, right, are I think fundamentally being challenged by AI as well, right? Now, I will not go into this slide, but again, the main points I'm trying to make is this, is our science is changing. Remember, in the old days, we had black box testing. Then we moved to gray box testing, and then we said, well, we got to open up everything, right, and do white box testing. Now, these are old concepts that go back to the 1950s, right? They are still relevant today, right? For each one of these, we have different methodologies, right? That are important, and for different kind of applications, we use different versions of this. I don't have time to go through this. That's another 2-hour discussion about these 3 methodologies. But give that some thought in your organization as well, right? One of the points that is really important there is the one in the middle. Generating use cases and test cases has emerged as the top application of AI in systems testing in our world, right? Testing has always been data intensive because we have so many data resources, right? From test cases to test results to changes. So we have to think carefully about how AI is changing how we operate. I've made some points earlier. I will skip on this in the interest of time, but ultimately it's if you're working with large language models, right? Just like Google in the early days came up with the large search engines, and then a lot of large corporations bought enterprise versions of the search engines for their own organizations, right? Today, the best approach that a lot of companies are taking, they don't want to rely on open source or DeepSeek or other kinds of, there's so much competition, and you don't know what you're getting from open source large language models, right? Ultimately, CTOs are very interested in having control over their own enterprise large language models, right? And I think that we have only scratched the surface, right? Scratched the surface. So you're going to hear a lot more about that. And the question will be who will be responsible for them, right? And like one CTO put to me, he says, look, language is very subjective. And large language models are not large computational models. They can't do engineering equations for you. And until we solve that problem, there's always going to be subjectivity. There's always going to be hallucinations problem, and testers will be needed for a lot of these kind of situations. So maybe the LLMs we see today are literally the first generation LLMs, right? There'll be more stuff coming out. I'm going to skip this in the interest of time because I think you all want to ask me a lot of hard questions, I hope. And then, because this is something that concerns me and concerns your profession, right? So hopefully you will think about these dimensions to it as well, right? I spoke a lot about design, right? Design is decomposition, right? And we know there are principles of good design, tight cohesion and loose coupling, right? Have we, in our use of AI systems, right, compromise the quality of designs? If so, are we going to get a lot of bad designs that will lead to all kinds of issues when we implement AI systems? So this is a big area, right, of research, both at the scientific world and And a lot of CTOs are concerned about that too, right? When you have data all over the place, we all know, remember you all, if you go back, you all probably learned about normalization, normalization of databases. You learned about, data flow diagrams and blowing the bubbles into smaller bubbles and having different layers. Those were just techniques for modular design. But if we compromise modularity in the IT shop, it's going to be a hellhole for software testers, right? So think carefully about design and whether systems can be tested at all, right? Then another dimension now is AI and cybersecurity, right? Now, a lot of the hacking is going to be cyber-based. I was talking to one of the CIOs, chief technology officers. He pointed out this area called identity management, right? Your signature, right? Remember when you go to a bank or you go to the grocery store, everything electronic, and they said, hey, sign here. How many of you actually sign it with that digital pen? You all do? I don't. I just draw a line or I put an X. Because I don't want them to have my signature, right? And as a matter of fact, if I go to 5 different grocery stores, I have a different signature for all of them. Because if they try to put it all together, even if they use a large language model, remember it's based on my first movement is detecting my next movement, right? Just like large language model, based on one word is detecting the next word, right? But if in 5 different places it finds the same thing, essentially it has your signature. So the value of signature, which is legally our signature is everything, right? Large language models have made it obsolete. Even your biometrics, remember your face images, remember with deep fakes, right? It's an obstacle. Can we even use this for identity management, right? So a lot of CTOs are thinking very carefully now. Of course, multi-factor authentication as a way of, cybersecurity identity management is becoming to the fore, and I think that's just going to expand simply because. So this is again a whole area that basically we'll have to use AI on AI. The AI can break us, but the AI can protect us as well, right? And we cybersecurity testers, right, better be good at it, right? It's really interesting. More and more I'm seeing the testing department for regression testing be merged into cybersecurity now, right? You probably are seeing it in your own industry as well, right? So this is, in some ways, a lot of CTOs are in technology-based industries are very, very concerned of this, right? Now, the other idea that was introduced by my research group many years ago, there's a paper in the European Journal of Information Systems talking about alignment. CTOs will be happy to sit and talk to you about strategic alignment for half a day because that's how their relationship with the CEO is always based on alignment. It's the technology supporting the business, right? And then within the IT shop, you have so many different groups all competing for the same budget. Are they aligned, right? And then software developers and testers, are they aligned? And then they can be aligned from a strategic perspective, but they may not be aligned on a capabilities perspective. You can be aligned in terms of strategy, but if your capabilities cannot match your ability to do the strategic responsibility that you have taken on as a technology officer, right? As a technology division, your company will not succeed. So now these concepts have not gone away. CTOs have focused on them for years, right? As a matter of fact, now there's a renewal of the alignment between all the AI that we are doing, right, versus the core infrastructure. As a matter of fact, FedEx, 7-8 years ago, set up a separate company called FedEx DataWorks and put all the AI there rather than put it right here because they were concerned about alignment with the business strategy within the same shop. And now they're talking about possibly, now they report to the two companies in IT report to the same chief technology officer, but slowly the alignment. So in some ways, sometimes you have to keep things outside your IT shop, right? Because AI can't be the excuse for packages not showing up at your customers' doors or planes not flying in that way, right? So you have to manage the risk differently. So in conclusion, essentially there are some things that risk management. Remember, one of the big improvements that science of testing brought was we started communicating with our the CTO started communicating with CEOs in relation to risk. Even we as individual testers, when we test something, we ask ourselves, which is the most risky one? I'm going to test that first, rather than trying to test everything. Can you imagine? So that language of risk management hasn't gone away. AI is not going to change that. So that's something. So we shouldn't just be talking about testing results for AI systems. We should go back to what we know, right? Same thing. Focus on AI as a normal technology if we want to make enterprise AI work. Enterprise AI work, like I said, is not working at the moment, right? Our role is expanding, right? Now, in terms of test automation, for a long time, we in testing have struggled with test automation. And we have had a lot of good tool sets. In the early days, the Mercury T tool sets were the first ones that came out. We have over the years, we have come up with a lot of tools, but they were always limiting in one sense. As a matter of fact, I used to say, and many people used to say, test automation is not about tools, it's about a culture, whereby every tester tries to automate as much of his or her work. Now, AI is just going to fuel this like anything, right? As a matter of fact, someone put it differently. He says, AI is test automation, right, on hyperfuel in that sense, right? And I think there's some truth to that. So this might be a time for you in IT organizations to kind of put some juice into test automation, because AI can do a lot of things for us, right, as a personal productivity tool. And finally, like I said, systems that can explain themselves. Remember, this is an AI concept in a whole area of AI called XAI. Not the XAI that is shooting rockets into space and blowing them up. That's, you all know that joke, right, about Elon Musk, right? What's his approach to testing, right? Just shooting these rockets up and all of them blow up, right? That's testing, and then we'll shoot another one, right? I think you all know, right, for the big contracts he got from the government, right? The Falcon and the Starship, right? 50% of the rockets he has shot up have blown up. Can you imagine NASA doing that in 1960s? The NASA director would be fired. Can you imagine? So in some ways, the testing approach he has is not the testing approach we test ourselves. We don't wait for things to blow up, and in that way we learn how to improve, right? That's not our approach. Now, finally, the last thing, last 2 points in my slide here, right? AI for software quality assurance may end up being more of a smart spreadsheet type productivity tool for us testers, right? Rather than a truly enterprise level testing platform, AI testing platform, right? So there are signs that this is starting to emerge of where we will end up with as a result of AI. Now, finally, you hear all this hype about AGI, right? CTOs are not concerned about it, right? A simpler term from AI from 1990s, AGI is nothing but common sense, right? AI systems are far away from getting super intelligence like Meta likes to call it, right? We are really, really far away. As a matter of fact, I don't even see that happening in my lifetime at least, right? So don't sweat about all this hype about AGI and how we'll all lose our jobs and AI will kill us and all that. It's just hype, of the technology wave, right? The key is for you to say, how can AI help me do my job better, right, as testers? Thank you.
Thank you very much, Professor. Maybe if you'd like to get some questions from the floor. Anybody would like to ask Dr. Professor? Or you prefer to do on Slido?
Maybe your AI wants to ask me a question. Now, my email is here if you're interested in any of these things, right? One of our challenges now is we always, in the US, we always want the best and brightest from all over the world to come and work on our science, right? If you're interested in software testing research, right, and want to do a PhD, we are very short of PhD students, right? Because AI is such a huge challenge for software testing, and we have we have been very successful in landing research grants in this space from companies and and from the National Science Foundation, but we are extremely short of PhD level talent. And the US has always believed in diversity. We bring the best and brightest from all over the world, make them work and compete together, and good things happen, right? So if you're interested in this, please, my email is here. Shoot me an email. We'll be happy to talk to you, right?
Right, very much. Thank you very much, Professor. Very informative and an eye-opener for most of us. Thank you once again.